Hello, my name is Rebekah Emery, and for this video, I'll be reviewing modules 1, 2, 3, and 5 for my Math for Teachers 1 final. Let's begin. For the first section, we'll be doing module 1. What can we do to solve this number puzzle? Our first equation is composed of a diagram which gives us 4 orange numbers with 4 yellow circles. The top right circle has a 6. The orange numbers are the sums of the yellow circles on either side. For instance, we need to find the number that can be added to 6 for a sum of 13. Our top left circle will be 7. Moving down from 6, we need to find the number added to 6 that will equal 21. We will add 15 to the bottom right circle. Next, moving across the bottom of our square, we find that our next sum is 19. We need to find the number added to 15 to equal 19. We will add 4 to our last yellow circle. Finally, by checking the left side of our problem for an accurate equation, we will determine if our equation is solved. 4 plus 7 does equal 11. This equation is complete and correct. Next, let's take a look at perimeter. Perimeter is the measure of the distance around a shape. Think of it like a fence. Using the same 9 tiles, you could make many different shapes. Each time a new shape is created, there could be a different perimeter. Using the 2 examples on the screen, let's see how this works. Which figure shows the greatest perimeter and which shape shows the least perimeter? Beginning with figure A, where the tiles are arranged in a single row, let's find out the perimeter of the shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now let's look at figure B and find its perimeter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice the arrangement of the tiles affected the perimeter of the shape. Later, you'll be able to experiment with tiles at your desk to design shapes that have different perimeters. Remember that shapes can be irregular and do not have to have strictly straight sides. So to answer our question, the greatest perimeter would be figure A, and the least perimeter is figure B. Can you find the 10th term in this sequence? Let's look at the number pattern. At first glance, the string of numbers 1, 5, 7, 1, 5, 12, 22, 35, 51, and 70 doesn't seem much like a pattern at all. Yes, the numbers increase each time, but the amount appears to be very random. Without the benefit of the illustration and the corresponding number sentences, it would be very difficult for you to understand this pattern. I hope that by cracking the code on this pattern, you'll gain insight on more complex ways that patterns can be discovered. We begin this diagram with 1 dot, then we added 4 dots to the diagram to form a pentagon. Look carefully at the pattern of each number sentence. Do you see what is happening? You are adding 3 to the last entry of the previous number sequence. The numbers in this complex pattern become more obvious when you look at the sequence equations. The formula for pentagonal numbers is Pn equals n times 3 times n minus 1 over 2. So using this formula, you can find any pentagonal number in the sequence. For instance, if we plug the number 10 for n in this equation, you can see that it gives us the correct pentagonal number for the 10th number in this sequence, which is P10 equals 145. How would you solve this pyramid problem? Well, the concept is simple. The blocks are stacked in a brick-like pattern. The brick that sits on the top of the 2 bricks is the sum of the 2 bricks below it that it is touching. Critical thinking comes into play because there are some important numbers that are missing. Where do you start? Well, we know that z and y equal 27, but how do we find z and y? So we move to the bottom row. You might first think, okay, this is easy. If the middle row is equal to the top row, then the bottom row should equal the middle row. But we soon realize that that doesn't work because x has to be used twice. We added to 2 to find z, then we also added to 9 to find y. We need a formula to help us solve the bottom row first. Moving from left to right, we need to add 2 plus 2x plus 9 to equal 27. Everything on one side of the equal side has to balance what is on the other side of the equal sign. I need to get x by itself on one side of the equal sign. To do that, I'm going to add 2 plus 9, which is 11. Then I'm going to subtract 11. Since I subtracted 11 on this side, I'm going to subtract 11 on the other side. Now I'm down to 2x equals 16, so I will divide each side by 2 to remove the 2 being multiplied by x. Now I have x equals 16 divided by 2, which is 8. When you plug in 8 into the pyramid for x, you are able to solve for z and y in the middle row. So 2 plus 8, you get 10z, and 9 plus 8 for y would be 17. Finally, you can check your work to see if your answers are correct by adding z and y together. Z equals 10, y equals 17, 10 plus 17 equals 27. Our answer is correct and our equation is complete. The next equation is actually a puzzle. How can we solve this puzzle using these clues? We are given the names of 4 men, 4 women, and 5 clues. Our job is to figure out who is married to who based on information that we are given. The ladies in this puzzle are Kitty, Sarah, Josie, and Ann. The men are David, Will, Floyd, and Gus. We are told that Floyd is Josie's brother. Josie and Gus dated some, but then Gus met his present wife. Kitty is married to Will, and it has 2 brothers, and Ann's husband is an only child. In order to solve this problem, we will need to find the most obvious clues first and then move on to the less obvious. By process of elimination, we will be able to successfully figure out who is married to who in this puzzle. First of all, Kitty is married to Will. Next, we know that Floyd is Josie's brother and that she dated Gus but didn't marry him. With that information, the only other option for Josie's husband is David. Third, we know that Ann's husband is an only child since Floyd is Josie's brother. It cannot be Floyd. The only option for Ann is Gus. That leaves the only option left for Sarah is Floyd. In the diagram, I have tried to highlight the information used throughout this puzzle to solve it. Notice there was a statement in the clues that was useless information. Hint, don't let that trip you up when you are solving problems similar to this one. Just know that there will probably be something extra in the clues that you will need to solve the problem. Moving on to Module 2. We will begin by looking at Venn diagrams. Our first problem is a Venn diagram showing a union and an intersection in the same problem. To solve this problem, it is important to look at the problem carefully and to remember the order of operation. Our problem is A union times B intersection C. Notice there are parentheses in this equation. If you do not regard the parentheses, you might come up with a totally different, wrong answer. First, you need to find the part of the equation that is in parentheses, which is B intersection C. The intersection is the part of the given sets that is in set B and set C. I remember the intersection sign because it looks like an N in the word and. This helps me to remember that the intersection is only the part that is in the first set listed and the second set listed in the problem. You will need to shade in the intersection of B and C. Next, you need to find set A and all of A and shade in that part as well. When you have successfully shaded this intersection of B and C and all of set A, you have displayed a union and an intersection correctly in the same problem. Now let's look at a Venn diagram using shapes and determine how to solve the equation C union H. The information on this Venn diagram can seem very random when you first look at it, but by breaking the information down into recognizable parts, you'll be able to see how to create you'll begin to see how to create a union between two of the groups. Use the information that is given to you. It is given for a reason. Sometimes we are given more information than we need for a particular problem. So look at what you are given and find what you need. I need to know what C and H stand for. In the information given, I see that C means circle and H means hexagon. Now, it is relatively easy to identify a union of circles and hexagons by placing a star on each shape. To fully appreciate our modern number system, it is good to have some understanding of how number systems throughout history have been developed and used. Let's take a look at Roman numerals. Although the Roman system of numeration is an ancient system, you will still find it used today. It is found on clocks, building facades, cornerstones, historical documents, and so on. They even use Roman numerals to identify each Super Bowl. This is still a very functional scale today. By reviewing the chart listed on the slide, you will see that the Roman numeral system is composed of letters, each representing different denomination. I equals 1, B equals 5, X equals 10, L equals 50, C equals 100, D equals 500, and M equals 1000. Roman numerals are written in groups representing greatest place value to least place value, and you cannot repeat any symbol more than 3 consecutive times. So how can you show a 4 or a 9 in any place value? We do it by entering a letter that represents the amount needed to subtract from a larger number in order to display the accurate amount for that place value. Important note, you cannot subtract a number that is less than 10 times smaller than the number you are subtracting from. In other words, if you want to write 99, you cannot write IC, which is 100 minus 1. You would need to identify the tens place as XC and then the ones place as IX, equaling IC, which is 90, plus IX, which is 9, which is 99. Having a smaller value between 2 or just in front of a greater value makes it clear that it must be subtracted instead of added. So let's find for the modern equivalent for MCMXXXBII, which is 1000 plus 1000 minus 100 plus 10 plus 10 plus 10 plus 5 plus 1 plus 1, which equals 900. Oh, my bad. Wait, notice that C with 100 is subtracted from M1000, which equals 900, and our answer is 1937. Let's switch gears and move to an alternative algorithm for completing multi-digit multiplication. I have found this method to be foolproof, especially for individuals that have a hard time maintaining straight columns of numbers, maintaining correct place value, etc., when using the standard method of multi-digit multiplication. We begin by setting up a grid with diagonal lines like the one on the slide in order to learn the lattice algorithm for multi-digit multiplication. We will systematically multiply each set of factors and record the product in the intersecting box. All products must be recorded as 2-digit numbers, so 1 would be written as 0, 1, and so on. Each box is divided into 2 triangles. The left side is the tens place and the right side is the ones place. So 2 times 3 is 6, 8 times 3 is 24, 2 times 2 is 4, and 8 times 2 is 16. I have highlighted alternate rows to make our next step more clear. Beginning with the ones place value, we add the numbers in each diagonal row. If we were to have a sum that exceeded 9, we would carry the tens digit to the next column. 6 equals 6, 4 plus 1 plus 4 equals 9, 2 plus 6 equals 8, and 0 equals 8. My bad. 0 is obviously 0. And our solution is the row total read from left to right would be 28 times 32 equals 896. Students often get frustrated when they are given this next set of problems to solve. They have to solve the same problem twice. Such a waste of time. Why do we even need to do estimation if we know how to get the right answer, right? Wrong. I know it may seem like extra unnecessary work to do each problem twice, but both skills are actually very important. So let's estimate the answer to this problem. 883 plus 465 divided by 134 by rounding to the leftmost digit. The rounding rule says that whatever place value you're rounding to, look to the right of it. If that number is less than 5, let it ride. 5 or more, add 1 more. That means we will round 883 to 900 and 465 to 500 because 8 and 6 are each more than 5. So we added 1 more to the hundredths place and in these numbers. But 134 rounds to 100 because 3 is less than 5. So we let the 100 ride and stay the same. Now we can solve our estimation. 900 plus 500, which equals 1,400, divided by 100, which is 14. And for the exact number, which is 10.05970149253731, that would most likely round to 10.06 or even just 10. Well, it seems like I'm running out of little time, so I will see you in the next video real quick.